Yes. Now we are going to discuss about hydrocarbons that alkanes. Preparation methods. Preparation of alkanes. Alkanes are prepared from different compounds by reduction. Reduction of alkenes, carbon-carbon double bond compounds. Reduction of alkynes, carbon-carbon triple bond compounds. Reduction of alkyl halides, RX. Reduction of alcohols, ROH. Reduction of aldehydes, RCHO. Aldehydes. Reduction of ketones, RCOR. Reduction of carboxylic acids, RCOH. Reduction of acid derivatives like acid halides, RCOX, maybe X will be chlorine, RCOC like that. Reduction of acid amides, RCONH2. Right. These are all different organic compounds. How to prepare? Okay. One by one we will do. First one, from alkanes. Okay. I'll give you simple methods to retain the concept in your mind. Alkene, first alkene. The alkene is react with nascent hydrogen. The reduction is take place in the presence of some reducing agents like Zn and HCl, okay, or we can use zinc copper couple in the presence of ethyl alcohol, C2H5OH, right, okay, or we can use it sodium in ethyl alcohol, sodium metal in ethyl alcohol. These are all reducing agents. These are all act as reducing agents, which reduces the neighboring substance. That are reducing agents or reducers or reductant, reducer. Then you are going to take a carbon-carbon double bond, sigma pi bond. Pi bond is a weak bond. These weak pi electrons are undergoes breakdown. Then to this carbon one hydrogen, to this carbon one hydrogen, they will get the carbon-carbon single bond. You have to take 2 moles of nascent hydrogen. So 1 mole is bonded to this carbon, other mole is bonded to adjacent carbon. We will get alkanes to get, right? Or we can use it a nascent hydrogen, that is for that reducing gases, or we can cause H2 gas, the presence of nickel or platinum or palladium catalyst. This is called catalytic hydrogenation. Catalytic hydrogenation, this is 2 hydrogen atoms are there in the H2 gas molecule, right? What happened here? This, the carbon-carbon double bond, this pi bond undergoes cleavage, and this pi electron shifted toward this carbon, then it get negative charge. By using the 2 electrons make a bond with this, and these 2 electrons are taken by this hydrogen, it get negative charge. Then this carbon is positive to this H minus is bonded. Is it clear? Right. Then you will get alkane will get alkane you will get. Okay. If it is a ethene, you will get ethane. Okay. If it is a propene, 3 carbon, a propene, right? Or hydrogenation. It is also called hydrogenation, addition of hydrogen, nothing but reduction. Then what you will get here also, you will get propane, you will get. Propane you will get. To this carbon 1 hydrogen, to this carbon 1 hydrogen is bonded. Propane you will get. So propene to propane. Propene to propane. Right? Is it clear? Right. Next, second one is from alkynes. From alkynes. The alkyne, carbon-carbon triple bond compound. If you add nascent hydrogen in the presence of the same, there is the catalyst. This is you can consider as A. By using this above catalyst, that is nickel. Here zinc, Zn and HCl or zinc copper couple in the presence of ethyl alcohol, right? Then what you will get the same thing here also, this here sigma bond and pi bond. So 2 pi bonds are there. You know, sigma bond is deeply seated and pi bond is it is formed by lateral overlapping. So the pi electron cloud is there above and below internuclear axis. These are exposed to outside. When the reagent is coming, these electrons are first attacked. So that's why alkenes are electron rich. These are act as a nucleophiles, right? Now here, so these hydrogens, that is by it breaks the 1 pi bond here first, and to this carbon 1 hydrogen, to this carbon 1 hydrogen is bonded. Then we will get, first of all, we will get here, first of all, we will get here alkyne becomes into alkene will get. Alkyne becomes into alkene will get. That is, to this carbon 1 hydrogen, to this carbon 1 hydrogen is bonded, right? Then the next stage, again you have to add another mole of, that is nascent hydrogen, the presence of the same catalyst. Then here also the pi bond is there. This pi bond undergoes cleavage, and to this carbon 1 hydrogen, to this carbon 1 hydrogen is bonded. Then finally you will get alkane. You will get alkane. You will get, right? So alkyne becomes into alkane. Here this carbon is sp carbon, and it is here becomes into first alkene sp2 carbon, next alkane sp3 carbon, right? So this is the ethyl. With 1 mole of this one, you will first you will get become into ethene, the alkene. Next you will get ethyl. You will get. Then finally you will get what? Ethane. You will get A. Ethyl, ethene, ethane, right? Or if you supply nascent hydrogen, this is you will get, there is 2 steps. First ethene, next ethane. Or if you supply H2 gas, the presence of nickel or platinum or palladium catalyst, okay, then here what you will get, the same thing here also. Here you have to use 2 moles of H2 gas. So there is 2 moles of H2 gas. Here 1 pi bond is replaced by 2 sigma bonds. Look here. In the case of here, the 1 pi bond is there. This pi bond is replaced by 2 sigma bonds. The major thing is 1 pi bond is replaced by 2 sigma bonds. 2 sigma bonds, right? So here also, here this pi bond is replaced by 2 sigma bonds. Next, another mole of hydrogen. It also, there is this pi bond, this pi bond. So totally here 2 pi bonds are break up, and you will get 4 sigma bonds. You get. Then you will get ethane. You will get, right? So how many moles of H2 molecules is required? 2 moles. To convert the ethene to ethane, 1 mole of H2. To convert the ethyl to ethane, 2 moles of H2 gas is required. Okay, right. Next one. If you take this ethyl, if you take one more example, that is a propane, you take a propane. A propane you take, right? Here propane. This propyne is also, if you pass, there is nascent hydrogen or H2 gas. So there is a nascent hydrogen, the presence of this catalyst. This is H2 gas, the presence of this nickel platinum palladium catalyst. Then finally what you get, propyne becoming 2. You have to add, this is 2 moles of H2 gas. Nascent hydrogen is directly just 4 moles of nascent hydrogens. Nascent hydrogen means the hydrogen which is prepared during the time of experiment in the lab. Just when it is prepared, that is called early born hydrogen, which is highly active. That the hydrogen which is stored or usage, that is less reactive. But early born hydrogen, which is called nascent hydrogen, which is prepared during the time of experiment, it is very highly active. So that's why we have to use this one. We have to prepare during the time of experiment from ZnHCl or zinc copper couple and CH5OH, right? Or you have to supply H2 gas by using the catalyst, that is nickel platinum palladium, that is called catalytic hydrogenation or catalytic reduction by the use of catalyst, right? Then, so for propyne, we need 2 moles of H2 gas or 4 moles of nascent hydrogen. Then you will get a propane. You will get. Is it clear? Okay, fine. So what will get? Propane will get. Right. Up to here, got it, my dear students? Can I erase it now? Fine. Yeah. Next one. From alkyl halide. From alkyl halides. The alkyl halide RX. They will here RCl something, okay. This undergoes reduction by the use of here also ZnHCl, okay, or zinc copper couple with ethyl alcohol or sodium with ethyl alcohol, right. So in the presence of this reducing agents, here they releases nascent hydrogen. You have to take 2 moles of nascent hydrogen. It breaks first here a carbon halogen bond. You know, compared to carbon, halogen is more electronegative. So it gets a negative charge, carbon gets positive charge to this, or hydrogen is bonded, you will get alkane and HX will get, right? So here alkyl halide is becomes into alkane. The alkyl halide becomes into alkane, right? Alkane, RH. Or we can use it here. The second, that is alkyl halide. We just supply H2 gas in the presence of nickel or platinum or palladium. Okay. Then here also the same thing has happened. That is H2 gas. That is 2 hydrogen atoms are there. Here this 2 electrons are taken by more electronegative. Halogen get negative charge, okay, and it make a bond with this H plus, and these 2 electrons migrate here, get negative charge, and this is R is alkyl cation. Now it is bonded to this. Now we will get RH will get alkyl, and HX is removed, right? You will get alkyl and HX, hydrogen halide. Then reagent alkyl halide, reagent, that is H2 gas, and a catalyst nickel platinum palladium, and product is alkane, and byproduct is hydrogen halide, HX. Or you take it here, in this case alkyl halide, it is alkyl bromide or alkyl iodide, it is react with HI. Okay. The presence of red phosphorus. What is the use of red phosphorus generally? Then what you will get here? This bromine, it takes 2 electrons because 4 electrons, it gets positive charge. And this bromine make a bond with this, right? But generally students are thinking like this. But here, what happened here? This bromine, it is bonded, it make a bond with this H, right? Then what you will get, HBr will get, and you have to take 2 moles of HI here. The second mole is there, right? The second mole, that is 2 moles. Second mole of HI also there. You have to take 2 moles of HI, right? Keep in our mind. Then another mole of HI is there. Once it will make a bond on this hydrogen, that is hydrogen iodide is there. Okay. So this is takes up the electrons. It takes up electrons, get negative charge. And then it make a bond with this. Then it takes up 2 electrons, get negative charge. Got it? Is it clear? Following, right? Yeah, that is HI. The second mole of HI. And this iodine is a negative, so that's why it make a bond with this. Then these 2 electrons together with this will get negative charge. Then make a bond with this. Right? Yeah. Now what you will get? RH will get this one. RH, alkane will get. And then this is HBr will get. HBr will get. And this is I2 will get. I2 will get. Is it clear? Right. So if you take it here, this is 2 moles of HI. So here also what you will get is here the same thing, that is we just represent for our convenience, so below here. So Ri is react with the HI. Then the presence of red phosphorus. Then what you will get here, this takes up 2 electrons. You get negative charge, and it make a bond with this H plus, and these 2 electrons taken by this one, right? Then you will get here I. Then have to take second mole of HI also. Then this second mole of HI, this is make a bond with this. Then these 2 electrons taken by this, it get negative charge. Then it is a positive, it is make a bond with this alkyl carbocation. You get RH, and then this is what? This is HI, it is I2. It is HI and it is I2. Right, got it. Okay. Then that means here, what is the use of red phosphorus? The use of red phosphorus is used for the what purpose? That is, here I2 is formed, right? I2 is a strong reducing agent. So that's why it is further react with HBr, will give back the backward reaction. So that's why this, to prevent the backward reaction, to increase the forward reaction, to favor the forward reaction, the red phosphorus is used. This red phosphorus combines with I2. When red phosphorus combines with I2, you will get a volatile compound, that is phosphorus triiodide, PI3 will get. It is a volatile compound, PI3. PI3 is a volatile compound. It is eliminated, it is released. Okay. So then, by that method, as soon as the I2 is formed, that is combines with the red phosphorus and removes as phosphorus triiodide, PI3. So that favors once the product side it is removed. Okay, as soon as the form is removed by red phosphorus, then the equilibrium is disturbed. So to form the very number of I2, again the equilibrium proceeds forward direction. That means it favors the forward direction. That's why you have to use red phosphorus. Is it clear, my dear students? So that is the use of that means it favors the reaction to take place in forward reaction. It favors forward reaction. Forward reaction. Right. Okay, fine. By combining with that. So this is from alkyl halides. So reduction of alkyl halides by the use of reducing agents, by the use of catalyst, and by the use of red phosphorus and HI. Is it clear? Fine. Okay. So this is alkyl halides up to here, and rest remaining from alcohols to these acids and acid derivatives. So we'll do the next second part of alcohol, that is alkanes preparation methods. Okay, my dear students. So thanks for watching my video. So just like it, subscribe it, and share to your friends. Fine. Thank you.